Well, welcome back, guys. We have made it to a tremendous topic that we tackle this year, and that's called the area between two curves. And this is such a huge topic on our AP exam. It's guaranteed to be one of our 6 free response questions. Now, the part that we'll be talking about today and tomorrow is probably only going to be part A of the free response question. But like I said, it is the biggest topic on our exam. Another thing to note is this is usually non-calculator. So it's a lot of mental math, so take your time with each step here. Now again, make a pretty close sketch to what I have here, and I even suggest using colors as well. The more curves we have, the tougher it gets, and I think the colors will break them up real nicely. So you notice I have 2 functions graphed, f of x and g of x. And my goal is to find the area between these 2 curves. Now, I can't certainly pick out a shape I recognize. I mean, I don't have a rectangle, a triangle, a semicircle, etc. So I do have to use an integral to find this area. Now our goal is we're going to create these rectangles inside here. And I'll start with a thicker one. And basically what I'm saying is if I can find the area of an infinite amount of rectangles in here, and add them all up, then I'll be able to get the area between these 2 curves. Now when I make these rectangles, I want to make them as thin of a slice as possible. So when I draw them, you won't see me draw, this that sort of looks like a rectangle here. I almost draw it as a straight line because again, I want the thinnest rectangle I can draw in there. So I'm going to start with a basic formula for area of a rectangle, which of course is just base times height. Okay, my base is going to be this distance here. And that distance, that little sliver, is my change in x, which I'm going to say is dx. Now, the height of my rectangle can easily be gotten. If I were to ask you how tall that was, and I assigned some numbers to it, let's say that had a height of 10 and that had a height of 3, I think you could easily figure out that the height of that rectangle would be 7. But since I don't have numbers, just think what we just did. We took whatever height this was and subtracted this height. So I'm going to say basically it's my green curve minus my blue curve, which in this picture is g of x minus f of x. Okay, to get the height of that rectangle. So again, I'm saying it's the green curve minus the blue curve represents that height. So to put this all together, the area underneath that curve is equal to the integral, and the integral is going to add up every possible rectangle. And please use brackets, just as I did here. G of x minus f of x dx. Now, I'm going to need to throw some bounds on here. Where am I integrating from? Well, if I were to draw in a bunch of slices here, and we are going to call them slices, I would go right until where they intersect here, and then I'm just going to drop that down and call that lowercase a. And again, I would draw an infinite amount of rectangles in here, and I would go right to where they intersect there, and I'm going to call that b. So I would integrate from a to b of g of x minus f of x. So I just want to be clear, this section in my blue here represents the height of the rectangle, and my dx represents the base of the rectangle, the change in x values. And we want that x value to be extremely small. The other thing I want you to star here is if you ever get confused of, which number you're subtracting, which I hope you don't, but if you ever do, just say to yourself, it's always upper minus lower. And you're going to use that term or phrase a million times this year. Upper minus lower. All right, so let's get our hands dirty and dive in. All right, question 1. Find the area between the curves. Y equals x squared plus 2, y equals negative x equals 0, and x equals 1. Now, like I said, these questions are typically non-calculator, so you have to be able to sketch this without the use of a graphing utility. So we've practiced drawing many random sketches on our bite-sized quizzes, and that was all actually leading up to this topic that we're doing. All right, so if you've got colored pencils nearby or markers, grab them. We want to draw each of these in a different color, and it will stand out. So let's start with our x-axis here and y-axis. X squared plus 2. Okay, x squared tells you you're a positive upward-facing parabola, concave up. The plus 2 shifts you up 2. So again, I shouldn't be saying anything new to anybody. If I am, we're in a little bit of trouble. Y equals negative x goes to the origin. Instead of having the positive slope, it's going to have a negative slope. X equals 0. I should cross the x-axis. That's what x equals means. That's your vertical line at 0, which of course is sitting then on my y-axis. And x equals 1 should cross the x-axis at 1. Okay, I'm going to carefully shade in between those 4 colors. Okay, so I'm looking between the red, the purple, the blue, and the green. And I'm shading all the area between them. This is the section that we are finding the area between. Make sure you come all the way down here. Don't stop at the black. That was just the axes. Okay, so we are finding the area of that section. Now again, it's not a geometric shape, so we can't just randomly grab some formula, and we're not approximating it, so don't do a Riemann sum on it. We are getting the exact area. So like we said in our previous situation, we are going to draw in an infinite amount of rectangles, but I'm going to start by drawing one in, and we want it to be as thin as possible. Okay, so I'm going to make it look like a straight line, but in theory, I should know that it's a rectangle. And I'm going to say, okay, what's the area of a rectangle? Well, area is just base times height, and we basically said that's always going to be your upper minus your lower. So if I go to the, and when I say upper and lower, I'm talking about that rectangle I just drew. I'm going to put a big dot on the upper end of the rectangle. And you can clearly see that dot is sitting on the red curve. So my upper, and watch my parentheses here, is x squared plus 2. Okay, that should be in its own set of parentheses, then a minus sign. The lower, I'm going to put a big dot on the lower end of my vertical line, and you can clearly see that it's sitting on the green line. Negative x. Again, it gets its own set of parentheses. This isn't an option. Okay, each of these should be in their own set of parentheses, the minus sign between them. Now finally, I'm just going to write my integral. And again, the integral is basically putting an infinite amount of rectangles in there and adding them all up to get the area. So I'm going to integrate. I'm not going to put bounds on at the moment. Here's the function I'm integrating. X squared plus 2 minus negative x dx. So there's my base and height. Now, this requires a little bit of work on your part. You have to figure out where you're integrating from. And basically what I like to say is if I were to take this rectangle and move it left to right, so imagine me picking it up and moving it to the left as far as I can and to the right as far as I can. How far to the left do you go? Well, hopefully you're saying you go until x equals 0. And how far to the right do you go? Well, you go to whatever this line is, and this was x equals 1. So my bounds go from 0 to 1. Okay, now the easy part is the integrating part. I'm just going to clean this up and then integrate. So I'm going to say 0 to 1. This is actually x squared plus 2 minus a negative makes that a plus x dx. Okay, now this is just a simple integral. There's nothing fancy about it. I'm just going to integrate each term. X cubed over 3 plus 2x plus x squared over 2. Don't forget you've got the bounds 0 to 1. Again, I'm going to use brackets. This is my upper minus my lower. When I plug my 1 in, I've got 1/3 plus 2 plus 1/2 minus, this all turns out to be 0. I'm going to get myself one big common denominator. Again, this is a non-calculator. You're going to have to be able to add fractions. For those of you that have issues with that, basically I turn everybody into a fraction. I look at my denominators, 3, 1, and 2. They all go into 6. So I'm going to rewrite this fraction with a denominator of 6, which means the 3 gets multiplied by 2, 6, and 3. So I've got 2 plus 12 plus 3 for a total of 17/6. And that is the area of that shaded region. All right, question 2. Find the area between the two curves, y equals 2 minus x squared and y equals x. So pause it, try it on your own. It's very important that you can sketch these correctly in order to get any of the math right. Okay, and this is a question you have to get a 9 on our exam. This is the easiest question you will see, and once we do it a bunch of times, you'll feel more confident about it, but we've got to be able to sketch these pretty freely and quickly. So pause it, sketch them on your own, and then compare with mine. All right, so hopefully your graph looked like mine. Hopefully you've caught that this was a negative x squared, which flipped that parabola upside down, still shifted yourself up a positive 2, and of course the nice equals y equals x. All right, so I'm finding the area in between those two curves. I'm going to go get my rectangular slice and stick it in there. Okay. Now, you'll notice one thing between the last problem and this problem. If you were to slide this slice, okay, do you notice how the top of this rectangle is always going to stay on this purple curve? If I moved my slice over here, would you agree the top is still on the purple and the bottom still on the red? If I moved my slice over here, the top is still on the purple, the bottom is still on the red. That's huge, and that's what makes these problems so simple. So keep that in mind as we go throughout this. But either way, I'm still going to say upper minus lower. Okay, so area is base times height, which is really my upper minus lower. Whoops. My upper, we just said, is on the purple. So that's my 2 minus x squared, minus my lower, which is on the red, which is just x. Okay, so I'm going to say the area equals the integral. I'm going to get my bounds in a moment. Parentheses for the first quantity, minus parenthesis for the second quantity. Don't forget your dx on there. Now, my bounds aren't as obvious as they were on the last one. If I were to keep moving these rectangles, sliding them all over, I would stop where these two intersect, and I want you to put a big dot there. That is our A, that is our lower bound. And I could go this way until these two intersect, which is over here, and put a big dot there. That is our B, that is our upper bound. Now, those aren't obvious points, and they didn't give them to us, so we have to be able to mathematically get those. So let's talk about how we'd get those two things. And if you think back, maybe just to Algebra 1 or even middle school, if you want to find where two things meet, they're equal to each other at those 2 points. So I just need to set those two curves equal. And you write down what you need to in your own notes there. If I want to find where the two curves meet, I'm setting them equal. So I'm going to get 0 equals x squared plus x minus 2. I'm going to factor that. Plus 2 minus 1. X equals negative 2, and x equals 1. And this should make sense. It looks like negative 2 looks like a reasonable amount. Positive 1 looks like a reasonable amount. So I'm going to say my bounds, lower, and then upper, from negative 2 to 1. All right. So you've got the hard part out of the way. The easy part now is just integrating. So go ahead, clean it up. And you can check with my math. I'll walk through integrating one more time. I think I can integrate each term separately. 2x minus x cubed over 3 minus x squared over 2 from negative 2 to 1. Again, watch. I'm using big brackets or parentheses when I substitute these in to keep them very clear. Distributing this negative sign is going to be huge. Be very careful with that. So I've got 2 minus 1/3 minus 1/2. I'm going to plug the negative 2 in. I've got negative 4. Negative 2 cubed is negative 8, but there's already a negative, so that's going to be a positive 8/3. Minus 4/2. At this point, I just grab my common denominators and go. I'm going to say everybody here can go with the denominator of 6. Everybody here can go with the denominator of 6. Again, this is not calculator active. Take your time. So I would get a 6, a 2, and a 3. That's 12 minus 2 minus 3. I get a 6, a 2, and a 3. 24, 16, and 12. Just take your time cleaning it up. That looks like negative 26. And again, watch this negative here. When I add that, I should, I believe, get 27/6. Okay, so again, take your time. I've got 2 more for you, so stay with me. All right, go ahead and find the area between the function f of x equals x squared minus 5x plus 4 and the x-axis. Okay, so again, get your picture set up. Here's my x-axis in blue. Now, you do want to make sure you know exactly where this graph is, so I'm going to take 2 seconds and factor it. I'm going to go minus 4, minus 1, tee it up. So I'm finding out that my roots are at 4 and 1. So 1, 2, 3, 4. And it's a positive x squared, which means it opens upward. So it should look like this. Okay, so again, you might have to take your time to get those roots. Lightly shade in the area that you want to find. And then draw in that vertical slice. Okay. All right, so this one's a pretty nice one. I would say once we have it sketched out. I'm going to throw my bounds on right away. If I were to move this as far over to the left as possible, they intersect right here at 1. And if I were to move this as far over as possible, they intersect at 4. Just want to go over that x-axis in purple so we can recognize the two different colors. And I just want to double check that my upper is always going to be on the purple line and my lower is always going to be on the blue line. Okay, so I'm going to say upper minus lower. The x-axis is really just in fact a height of 0 minus the curve x squared minus 5x plus 4. Whoops, and make sure you have the dx there. All right, so be real careful when you clean that up. It's extremely important that you put 0 first because you have to make sure that you negate all of this. Okay, it's upper minus lower every time. Don't skip any steps. So 1 to 4, so I actually have negative x squared plus 5x minus 4 dx. And if you've got this part, I'm going to say we're kind of good to go for right now. Obviously, we would just integrate, plug in the upper minus the lower. But I am focusing on the setup today, and we'll work out the math in class. All right, I've got one last one for you. Stick with me. All right, so last one, and this one's a little different from the previous two, so take your time on this one. This is a very typical AP problem. F of x equals 3x cubed minus x squared minus 10x. G of x equals negative x squared plus 2x. Now, I certainly know what a cubic function is, but I need to be pretty exact here. We certainly know our cubes look like that. But I'm going to take the time, factor, and get my exact roots. So I think we can say we can all pull out an x. So we've got 3x squared minus x minus 10. We're going to have to factor, and of course that looks like a little guess and check. So I'm multiplying to my first term, which is 3x and x. 10, basically 10 and 1 or 5 and 2. Those are my only two options. Hopefully you're pretty quick with the trigger there. I'm going to go 5 and 2. Probably a positive 5 and a negative 2, I would say. And just a quick reminder, you want the two inside terms to make this inside term. So positive 5 and negative 6 certainly make negative 1. All right, if I tee those up, I've got my x equals 0, x equals negative 5/3, and x equals 2. Those are where I should be plotting the roots to this function. So let's go ahead and get those on there right now. X equals 0, x equals negative 5/3 is close to negative 2, but not quite there, and positive 2. Okay. Now, since that function is a positive x cubed, it's going to start low, just like x cubed normally starts, and get higher. So I have to cross through all three roots, so I know it's going to come up, down, and back up. All right, so like I said, we know what x cubed looks like. We just have to make sure we go through those three roots. I need to do the same thing with g of x. I'm going to quickly pull out an x. Actually, I'm going to pull out a negative x. So I'm left with x minus 2. If I tee that up, I should get x equals 0 and x equals 2. So you'll notice these two functions have two of the same roots. So I'm going to put those two right on top, 0 and 2. It's a negative x squared, which tells me I should be going downward. Now, I graphed it this way on purpose. The question is, certainly you can see one section right away. And let's go ahead and shade that in. Certainly this section, we can find the area between. But do they ever intersect again? Clearly on this side, if one's shooting up and one's shooting down, they're never going to intersect. But on this side, the way I drew it, maybe, maybe not. So let's set the two functions equal and see how many points of intersection we should get. All right? So again, I'm going to take my two functions, 3x cubed minus x squared minus 10x, and set that equal to negative x squared plus 2x. This will tell me all the places they should meet. So of course, set it equal to 0, solve, and we'll see what we get here. Minus 12x, I believe, equals 0. I can take out a 3x, and I get my x squared minus 4. So that's telling me I should intersect at 0 and plus and minus 2. These two functions should intersect 3 times. Well, clearly we see it happening at 0. We see it happening at positive 2, and it's telling me they should intersect at negative 2. So I just kind of have a not to scale picture, so to speak. So I'm going to extend my green line here and extend my orange line. Maybe kind of draw it a little better. And they should be intersecting, and this should be at 2. So again, not totally drawn to scale. I'm going to move my 2 over. They should be intersecting at 2. So I want you to note how important this is. There's actually 2 sections that you have to find. There are 2 different areas that you're finding. Now, because we have 2 sections, we need to draw in 2 separate rectangles and write 2 separate integrals. So let me say that again. 2 different areas, 2 different integrals. So I'm going to draw my first rectangle in. Okay, and you'll notice, pay attention, the upper's on the orange, the lower's on the green. And that's why I think the colors are so helpful. When I draw my rectangle in this section, you'll notice the upper's on the green and the lower's on the orange. So again, 2 different rectangles with 2 different integrals. All right, let's start with this section. I would say this is the integral from. The left bound where they intersect is 2, negative 2. And they won't intersect again till 0. Okay, and remember, you are saying upper minus lower. Upper is my orange curve, which was that cubic. 3x cubed minus x squared minus 10x minus the lower, which is the green one, negative x squared plus 2x dx. Okay, now you have to add on to that the second integral because you want the total area. So let's get a huge plus sign there. We're adding on another integral. This time, and this is representing this section here, I would say they intersect at 0 and then intersect again at positive 2. Okay, upper this time is the green curve, so negative x squared plus 2x minus the lower, which is your 3x cubed minus x squared minus 10x dx. Okay, so 2 separate integrals, 2 separate areas, and we're going to add them together to get the total area. Now, like I said, we're not going to evaluate it right now. Our focus on this video was just to worry about the setup. So, hopefully you have good notes with you. Come to class ready to go, and we look forward to any questions tomorrow. Have a great night.